All right, so now let's talk about finding the inverse of a function algebraically. All right, so going forward, what we should do is we should go ahead and identify our inverse function by writing it as f of -1 x. That's how you do it symbolically. All right. Now, steps to going ahead and finding an inverse and determining whether or not I need to do any restrictions on that is going to be included here. So verify if the function is invertible. If not, restrict the domain so that it is. Basically, what you're wanting to do is go ahead, look at the graph. Does it pass the horizontal line test? Yes or no? If it does not, okay, how do I need to adjust it so that it does pass the horizontal line test and would be invertible? So that's step number 1. Step number 2, replace f of x with y. That way it just, makes a little bit more sense for our next step where we swap x and y. And then what you will do after that is solve for y and then rewrite y as f to the -1 of x. Okay, so let's try that right here with this function. First thing that I'm going to do is I'm going to verify that it is invertible. Well, let's look at the graph. I shouldn't even need to look at the graph. I have 1/5x. What kind of function is that? Linear. Is a linear function going to pass a horizontal line test? It should. About the only way that it won't is if the function is a horizontal line. So basically, if my graph was y equals 2, well, that would fail. But this one definitely is going to pass. So I have a linear function. And so I can go ahead and find the algebraic inverse of that. And so here, instead of having f of x, I now have y equals 1/5x. Okay, now let's swap x and y. So now I have x is equal to 1/5 y. Okay, now I need to do step number 4 here and solve for y. So in order to get y by itself, it's multiplied by 1/5. So let's multiply by 5, multiply by the reciprocal. And that will go ahead and get that 1/5 over to the other side. And so that gets me that y is equal to 5x. Okay, last step, I'm going to write that as f inverse of x is equal to 5x. All right, so now that I've got that, I can go ahead and I can find the information that I need to, so I can go ahead and graph this. So what I do is I just put them in y1, y2, get my table, and go ahead and graph. That is, of course, if you don't remember the steps to graph a linear function, which I really hope you do because it's pretty basic. But if not, let's just talk about that. If I have 1/5x, that's technically 1/5x plus 0, y equals mx plus b, plus 0. 0 would be your y-intercept. And then my slope is 1/5, up 1, right 5, up 1, right 5. And then I can continue the trend and go down 1, left 5, and down 1, left 5. All right, so I've got that. So that is my original f of x. My inverse function would be 5x. And again, that's 5x plus 0. So it's, again, got my y-intercept at 0, except here, my slope is not 1/5, it's 5/1. So up 5, 1, 2, 3, 4, 5, right 1. Up 5, right 1. And then I'm going to continue and go the opposite one, down 5, left 1. Okay, so I've got that. So there's my function and its inverse, both graphed, and we should be able to go ahead and identify our domain and range. Again, it's a linear function. Does a linear function have anything that's going to restrict it going to side or up or down? No, it does not. So my domain would be -infinity to infinity, and my range would also be -infinity to infinity. Does that change for the inverse? Nope, because it's also a linear function. Got -infinity to infinity and -infinity to infinity. Do linear functions have asymptotes? No. So not doing that. Okay, let's look at number 3 right here. If I was to go ahead and look at this one. I've got a square root. So step number one, I need to go ahead and see, what does this graph look like? Hopefully you remember from semester one that the graph of a square root function is going to go something like this. So I will go ahead and tell you, yes, it will pass the horizontal line test, but let me go ahead and prove it to you. And there you have it. There's a graph right there for you. And again, I can go ahead and just do that and grab the table of values in here and go ahead and graph it. Again, hopefully you would remember from when we did this that it was just your standard square root function, and it had been dropped down 4. So we had a vertical translation of 4. And do I have an asymptote on a square root? No, I do not have an asymptote on a square root function. A square root function, or rather an asymptote, you have to consider what exactly an asymptote is. A vertical asymptote exists when the function would be undefined. And so that's frequently where, say, for example, if I'm dividing by 0, so it's something that causes an instantaneous problem, and it's only at that number where it's kind of always going to be approaching that. Then you have a horizontal asymptote, where that's kind of just guiding your end behavior on those far extremes. And it's something that it's always approaching while never touching. And so with a square root function, I don't have something that it's always going to be approaching while never touching, and I don't have anything that it's that causes it to be undefined. So I just have the graph of my function here. And I would just use the table of values to go ahead and graph it if you wanted to. All right, so there's the graph of my inverse function. All right, so let's go ahead and algebraically find the inverse of this one. So I have Step number one, rewrite it as y equals 2 square root x minus 1 minus 4. Okay, now I can switch x and y. So not y here, it's x is equal to 2 square root of y minus 1, and then that's minus 4. Okay, so step number one, I've got to get this y by itself. So in order to do that, I need to add 4 to both sides. So I get x plus 4 is equal to 2 square root y minus 1. Next step to get y by itself would be I would divide both sides by 2. So I get x plus 4 divided by 2. And then my next step would be, helps if I write the other side, equals the square root of y minus 1. All right, so now in order to get y by itself, I got to square both sides to get rid of the square root. So that's going to get me x plus 4 divided by 2 all squared, and that's equal to y minus 1. Okay, and then my last step to get y by itself would be I would add 1 to both sides. So essentially I get y is equal to x plus 4 over 2 all squared plus 1. I'll go ahead and make a comment here that you could rewrite this equation a bunch of different ways. You could go ahead and distribute all that out, but another way, I think my preferred way of seeing it, is it required? No. Does it make me happy? Yes. Would be x plus 4 squared over 4 plus 1. That just gets you a quadratic, and you can kind of see all your transformations on that. You can see that this was a quadratic function that has had a vertical dilation by a factor of 1/4. It has had a vertical translation up 1, and it also has been horizontally translated left 4. I just kind of like doing that, and because again, that would also help you if you were to go ahead and just graph it, because then you could find that without your calculator. Obviously that's not something that I'm requiring of you or expecting of you, but hey, it's something that you could do. But let me go ahead and put that into the calculator and graph it. So there we go. Got that put in the calculator, and this is what I have. Now, does this look like it's just been reflected over the line y equals x? there's a bit more going on there with that red graph versus the blue graph. Why do you suppose that is? Well, that's because a square root function does have limitations. I cannot take the square root of a negative number, but I can, however, square a negative number. So there's no input value for a quadratic function that has a limitation on my graph, but I do have input values that have limitations on my square root function. So naturally, the original function is actually restricting my domain because of that, because it's right here. So I actually have a natural restriction right here. If you consider the domain of the function right here was from 1 to infinity, well, that became the range over here on this function. If I go ahead and look, the bottom of this graph is over here at 1, and it goes from 1 and it goes up. And then the range of this function, again, it was at -4 all the way up to infinity. Well, if I go ahead and kind of consider where -4 is at on this red graph, it's right here at the vertex. And so if I cut it off right there, that would allow my graph to now pass the horizontal line test because none of this part over here on the left would be there. And it's only from that vertex and to the right. And so that gives me only a portion of my graph that I actually have for my inverse function. Okay, and you can see right now I've got that up here. And so that gives us what we've got down here. So now our domain of our original function, we've already said it several times, but let's go ahead and say it one more time. It goes from 1 to infinity. It includes the 1. The range will also go from -4 to infinity. That means over here, the domain of this one was -4 to infinity, and the range was from 1 to infinity. And I already addressed it. Does it have an asymptote? No, it does not. No asymptotes. Nothing to be concerned about there. Okay. It looks like I'm almost up on time for this to let me do that. So I might do just one more video to kind of explain one more thing.